All right, let's get started. Let me just send a message through Slack that webinar is live. All right.
All right.
So welcome to everybody who's joining right now our webinar. So hopefully you're having a great learning week. Once again, my name is Javier Ortiz. I'm your mentor throughout this nano degree data engineering. So today, what I want to do, I want to give a walkthrough of the current project that you have to do. Now, before that, just a couple of reminders. Just to remind you that you can schedule a one-on-one mentor meeting with me through my Calendly account, which I've posted many times in the Slack channel, our private study group Slack channel. So I recommend you do that. And we have a project due this April 16th. So that's next Tuesday. So hopefully everybody has finished the first lessons, the one about relational databases, and you are already working on your project. And this video, this walkthrough, hopefully will clear questions that you have about the project. And that is the plan. So let's get started with the walkthrough. And I'm going to let you guys ask questions throughout the walkthrough just to clarify things. And at the end, if there are any other questions, we can go over them. Okay, so let me just share Safari window with you guys, and please let me know if you're able to see it.
Okay. Yeah, I can see it.
Awesome, awesome. All right. So I'm going to disappear for a second here, and the view is clear of the window. Nothing is like obstructing the view.
No, it's all clear.
It's all clear. Awesome. Then let's do it. All right. So let's go over the project. So the project is data modeling with Postgres. Now the previous lessons hopefully prepare you for the project. And let's just go over the introduction. And let me just mute you guys. Awesome. Just that's it. Okay. So basically, you are a startup called Sparkify, and brings you on board to create a database. So they're like a streaming company, and basically the analytics team is interested in understanding what songs users are listening to. And currently, what they have are a directory of JSON logs on user activity and a JSON metadata on the songs in their app. Okay, so the JSON thing, let me show it to you. How does it look? So the JSON log files currently look something like this. One second. All right. So basically, they have these files here. You can see on the left side, and they have like individual files that contain the information of the user activities and that contain the information of the different songs that users are listening to. So this is a hassle because you have to, in order to understand like the information that this JSON files have, they have to open each file, and you cannot query the different information held here. So that's why they bring you on board to create a database. So you're going to define a fact and dimension tables for a star schema and write an ETL pipeline that transfers data from files into local directories in these tables in Postgres using Python and SQL. All right. So the first part is the creation of the tables. This is really straightforward because it's what you saw during the lessons. But I know that the ETL pipeline is something that you didn't cover in the lesson, so that can be a little bit intimidating. But don't be intimidated by it. ETL basically it stands for extract, transform, and load. And what you do is basically extract the data from the files that I show you, the JSON files, and transform it through Python so that you can load it into the different databases that you're going to create. So that's basically what it stands for. And so that's basically what we're going to do with the ETL pipeline. So don't get intimidated by it. All right. So it talks a little bit more about the JSON files. That you have like a specific file for each song that contains information and basically the number of songs, the artist ID, the artist latitude, artist longitude. So all the information that each file has. And the log dataset, basically each of these files contain all of this information, the artist, first name, gender, last name, length, level. So it's basically walking you through the different data that you hold here. And once you extract this information, you're going to transform it into a data frame, which is a pandas data type, and that is going to hold all this information that for your easy manipulation of the data. All right, now let's go over the project instructions. So here they already provide you with the different tables that you're going to create. And the different tables, you have a fact table that, as you remember from the lessons, the fact table is a type of table that describes an event. Okay, this specific event is the data associated with the song plays. And this is the information that you want to include in that fact table, right? And then we have our dimension tables. And dimension tables are the tables that describes the different entities that are relevant for this company, for this startup. We have users, and this is the information that you want in the table. Users, you have songs with the relevant information, artists, and time. All right. Then the project specifies like different documents that you will have to work, and I'm going to explain it in the next window. And it provides you with the project steps, which we're going to follow right now through the project walkthrough. All right, so let's dive into it. Okay, so once you click here where it says Project Workspace, it will take you to this window. As you can see it, Project Workspace, and it takes you right here. I'm not going to open it again because if you open it like twice, it doesn't like it. Okay, so this can be intimidating because it's a little different from what you saw. I know some of you were expecting like a Jupyter notebook, and instead of that, you have like a lot of, well, not a lot, but you have 6 documents, all right? So, but let's tackle it step by step. Okay, now the project step says the following. First, you're going to create tables. And you're going to write the create statements in the SQL queries.py to create each table. All right. So what we're going to do here, we're going to open this document, SQL queries. So you go here and right-click and open it. And here you have a Python document. And what you're going to do, you're going to write the create tables statements for each one of the tables that you already defined right here. Okay, so let's get started. Let's start with the songs table. I mean, you can do it in any order. You're going to fill out the 5 tables that would be fine. I'm just going to start with the song table. And here you're going to do what you already did on the lessons, which is the create table if not exist, and then the name of the table, which is songs. You have it right here, songs, and this is the information that I want to include here. So I'm going to just do it like this, and don't forget to specify the data type. So for song ID, it can be an integer, but it can also be a text. So I'm just going to go with text. Later, you will be able to specify based on the needs of the actual data type. So here, and don't forget to specify if the primary key, not no primary key, and then title, specify the different data types, artist ID, I'm going to go with bar chart. You can also write text here. For year, I'm going to go with an int, and you can also do it this way. So that is a little bit nicer. In duration, I'm going with maybe, I don't know, maybe a float, but it can also be numeric. So it's up to you. So right here, I already created my first table. Okay, so you're going to write the create statements for each one of these tables. The song play create the table, and if you have questions on what columns you're going to add, you have it right here in the project instructions. Song plays with this columns, user with these columns, artist with these columns, time with these columns. Any questions so far? Let me know through the chat if you have any questions about this part of writing the create tables statement. I'm just going to give a couple of seconds. Okay, no questions so far. So this is the first part of the project. Let's move on to the second step, which is write drop statements in the same document to drop each table if it exists. All right. So this was actually my first mistake during when I first completed this project, because I just like went straightforward drop table, and then let's say I want to drop. I'm just going to write the song because I already did that one. Drop table songs. Okay, which is the correct way to doing it. But since most likely we're going to run this statements before the create table one, you haven't created the songs table if you run this first. So since we don't know the order we're going to run them, don't forget that if it exists statement. So you're going to drop the table just if it exists. So drop table if it exists, and then the name of the table, which is songs. All right. And once again, you're going to do the same for each of these tables. Okay, so this is like pretty straightforward. So let me know if you have any questions about drop statements through the chat. All right, cool. So don't forget that if it exists is really important. Okay, let's move on. Then step number 3 says run create tables.py to create your database and tables. All right, so first I'm going to open it so that you can look at what is inside here. And we have here a function which creates database, basically connects to database, creates a connection with the database, creates a database, I'm sorry. And then here this function will run the drop tables queries that you already wrote, and this will run the create tables queries that you already wrote in the previous steps. Okay, so basically when we run this file, we run these queries that you already wrote. Okay, so how do you run it? So here in the launcher, we have a terminal. So you can just click on the terminal, and here you're going, since this is a Python document, you're going to write Python, okay? And then write the name of the document, createtables.py, and press enter. And if it runs correctly, you should see nothing, basically. Okay. All right, so this is how I know it ran correctly. And that's how you run. Another way of opening the terminal is going to new, here in file, new, and where it says terminal, and you'll have another terminal. All right, so I already ran it. And so any questions on running the terminal? All right, great. So no questions about the terminal. So let's move on. Now what you're going to do, you're going to run test, and you have an IPython notebook to confirm the creation of your tables with the correct columns. Make sure to click restore kernel to close the connection to the database after running this notebook. So you have this test IPython notebook, and it basically is a series of SQL queries. Okay. Now, if I run it right now, I won't get anything because I didn't write all the statements. So it will have an error, but let me show you a previous one that I already did. It was the test. Okay, so you won't get this results yet because this is my final product. The first time that you run these, you would only get this, the headers of the columns. Okay, so once again, this is really important. You won't get this data the first time you run it. You would only get the headers of your columns: song play ID, start time, user ID, level, song ID, artist ID, session ID. Okay, so let's focus on the songs one, which is this one. What you want to check here is that, once again, you won't get this data yet because you haven't populated database, the table. You will only get the headers, which is what you wrote in the create tables statement. So song ID, title, artist ID, year, and duration. You want to check that these columns match the ones that you wrote here in the SQL queries. And here it says song ID, title, artist ID, year, and duration. And here these columns match. So that's what you're going to look for in each table. Any questions so far? Please let me know through the chat. Awesome. Okay, let's move on. So once you're done with that part, you're going to run the test. Oh no, that's what we already did. Oh, I forgot the restart kernel. So here you specify in the test, you specify you made a connection to the database. So you need to close that connection. So what you can do is go here where it says kernel, and you can restore the kernel, but I prefer shutting down all kernels. And you shut down, and basically what you do, you stop the connection to the database, and you won't lose any data. You just reestablish the connection. All right. So you won't lose anything. You just need to establish so you can run these files again. Okay, so don't forget to do that. Now let's move on to the build ETL processes. Okay, so follow instructions, ETL notebook to develop ETL processes for each table. At the end of each table, or at the end of the notebook, run test to confirm that records were successfully inserted into each table. And remember to rerun create tables to reset your tables before each time you run this notebook. Okay, so let me open this document, ETL. And here, let me just rerun the create tables. Oh, sorry. I misspelled it. Create tables of pi. Awesome. Okay. So I have my ETL Python notebook. And the way you run these blocks of code, you can press the play button, or you can press the shift and enter command. And if you see a number here, that means that the block ran successfully. This is going to import the different libraries that you need. This is going to make a connection with the database. And here they already specify a function for you. What this function does is that basically gets the information, the files that are written here in the file path, and it writes all the names of the files here in this list, all files. So let me run it. Okay, now let's get started. This document, which is the ETL, basically goes step by step on how to extract, transform, and load the data from these files, JSON files, into the databases, into the tables that you're creating here. Okay, so that's why I told you not to be intimidated by the ETL part of it, because you have to follow a step by step, right? So here it says, okay, use the get files function provided above to get a list of all songs JSON files in data song data. Now the way you do that, you basically use the get files function that they already defined for you here, and get files, and you're going to write the file path. And the file path, they give it to you right here. Don't forget to use quotes, data song data. What it's going to do, okay, let me print it for you so that you can see what result it gives you. Okay, as you can see, this is a list of all the different files the names of the file paths for each file contained here in the song data JSON log. All right. So you have a list of all these file paths, and it says select the first song in the list. So here we have where it says song files. We have this list, and we want to select the first one. We want to select this one. All right. So in Python, how do you select the first element of a list? That's right, song files and index 0. And that's it. Let me run that one. I already selected. Let me print it for you so that you can see it. File path. And here it is. All right. And finally, you're going to read the song file and view the data. So they already provided you with, here it says project datasets, with a way of loading a JSON file into a data frame, which is the pandas data type that we're going to use for the transform part of the ETL. So I'm just going to copy it and put it here. So it's pandas that you already imported. Read JSON, the file path is, and we have the variable file path, so you don't have to change this. And lines equals true. And here the df.head basically prints the first lines of these data frame. I'm going to run it. And since we only uploaded one file, you will only have one song right here. Okay, any questions with this part? Let me know through the chat, please. Questions? Nope. All right, let's move on then. Okay, so now you have a data frame that contains the information about a song. Okay, so let's follow the steps. Songs table. You're going to extract data for songs table. Select columns for song ID, title, artist ID, year, and duration. So the way we do this, and I'm going to share some resources with you, a list of resources that I used to solve this. I have them here in a folder. So the first resource that I used was this one, the .lock, to select columns in pandas data frames. And I'm going to share this with you. It basically tells you how to select certain columns using .log. And here it says that basically you can write the rows that you want and the columns that you want. So what I'm going to do, I'm going to write df, then .log. And since I want all the rows, I'm going to use this indexer that tells me that I want all rows. And here, I'm going to write the name of the columns that I want to select. So song ID, and make sure that you write it exactly as you have it here in the data frame. Song ID, then the title, which is right here. I forgot the quotes, don't forget them. Then artist ID, which is right here. Then the year. And then the duration, which is right here. Right. So it says use df values to select just the values from the data frame. So once again, I'm going to share the resource with you. Where's, oh, I don't have the values one. I have the list one, but don't worry. It's pretty straightforward. You basically just write .values and you get the values. All right. And then index to select the first record in the data frame. Once again, how do we access the first record? Just with an indexer with index 0. And convert the array to a list and set it to song data. So how do you convert this to a list? I'm going to share a resource for you where it tells you how to do it. And it's right here. So we're going to use the .toList and basically creates a list for us. So, and I'm going to run it. And here we have the song ID, title, artist ID, year, duration from this data frame, but we're converted into a list. Okay. And now here what it's going to do, we need to insert this data into our table, okay? So you need to go back to your SQL query and write the insert query, and what it's going to do is going to populate it with the song data, which is this list that you already specified. Okay, so I go here, insert, and let's go to song table. Here, insert into, and the name of the table is songs, and then you're going to specify the different columns that you wrote. And we don't need any of this. The data types are already defined, so you don't need them. All right, almost done. Okay, now here, please don't forget that you need to specify the values. Now, what are the values? The values are, are this one. But you don't want to write them by hand because that wouldn't be scalable. So just what you're going to, and since we already know that we're going to use this one, so we're going to use this symbols, which is the percentage sign and the S for string, that is going to change these values for the values that we specify here in the song data. So we have 1, 2, 3, 4, 5. So I'm going to write 5 of those, 3, 4, 5. And this is my insert query. And once again, I won't run it because I will get an error because I didn't write everything. Maybe it does run, but and don't forget to save your Python, your documents before you run it. Let's see if it runs. Yeah, it has an error, but yours will run correctly, hopefully. Okay. And so this is the insert, how to insert values into your different tables. Any questions so far? No. Awesome. All right, let's move on. So for the artist table, it's exactly the same procedure. So I'm not going to go over it. You're going to select the columns. You can use the .log again. Use the df.values and select the first and only record, and then convert it to a list. So that's what you're going to do here. And here you're going to do the exact same thing. You're going to write the insert statement, and don't forget the values, and here that they're going to be replaced with these values you specify right here in artist data. So that's it for songs and artists. So let's move on. Now, process log data. You perform ETL on the second data set. As you remember, right here in data, we have 2 data sets to create the time and users dimensional tables and the song place fact tables. So use the get files function provided above to get a list of all JSON files. So you already know how to do this because it's the same process that we follow right here. But I'm going to do it just so that you can see the data frame that is going to be created. So instead of this file path, you're going to follow this file path because it's a different file, a different folder. So let me run it. Okay. Now select the first log file. These once again will give you a list of all the file paths contained here. Since we just want the first one, once again, we just index it. And then you can use the same statement to read it into a data frame, which is this one. All right. And since file path is this variable, so you can leave it like that, and you get this data frame. As you can see, it has different information about the songs that the users are listening to. Okay, let's move on. So this is the same as we did before. Timetable. So you're going to filter records by next song action. So we're working with this data frame, and we want to filter the records by the next song action. As you can see, the next song is in this column that is called page. when you look into this document, you will see that you will have a Boolean indexing using .log, which basically you can specify a column and the different and the value that you want that column, and it will filter all the rows that fit this description. Okay, so in this case, we want to filter the next song action, which is in the page column. Page, and oh, let me write it this way: df.page, df page column, and we want that to be equal to next song. All right, and so this will give us the next song. And let me see if I wrote it correctly. Let me run it. All right, and yes, as you can see here in the page, I only have the rows that fit this description. Now we're going to convert the TS timestamp column to datetime. Hence, the current timestamp is in milliseconds. So I'm going to share also a resource for this to convert a column, the values of a column, into datetime. And basically, I just Google like pandas, convert a row to datetime in milliseconds. And here it gives us a way. Basically, you can run the pandas dot to datetime, and you can specify the column that you want to convert to datetime and the unit that that column is using. So I'm just going to copy this and here. And obviously, we don't have a Unix time. In our case, it's right here. The TS is the one column that holds this timestamp information. So I'm going to write here TS. And this stands for milliseconds. So let me do it, and we run it. And yes, it's converted to the datetime. Okay, awesome. Now extract the timestamp, hour, day, week, or year, month. Okay, to a list containing these values in order. Use pandas DT attribute, and if we open this, it will send you to where is it? I think it's this one. So it basically tells you that you can access, yes, with the .t attribute, DT attribute, you can extract the year, the month, the day, anything you need. And here is the place that you would do that. So first you're going to extract the timestamp. And the timestamp is basically the T. So you can just write the T. And then you're going to extract the hour. So you do the T.T. Here you can use this timestamp, sorry, this one, or you can use this one that is in the DF. So in that case, you would write it df.ts. All right. Then time DT attribute and specify if you want the hour, you will write hour. And you should look into that document to know what do you have to write for each DT attribute to get the week of year, month, year, and weekday. From the TS column that you already have it in here, right? So any questions on how to get the different time data from the timestamp? Let me know through the chat, please. Nope. All right. Great. And here you're going to specify the column labels, all right? And the column labels, you can name them accordingly to the table that you wrote here in the timetable, in the table create, which you have right here. So I want to get this, right? Okay. So basically, you're going to write them here. Just write the name of the tables, the name of the columns. I think the first one was start time, then hour, day, start time, and the other one was hour, and so on and so forth. Okay, So you have the different series of data from the timestamp, and you have the headers of the columns right here. Now it says specify, oh, already did that. Create a data frame, timedf, containing the time data for this file by combining column labels and time data into dictionary and converting this into data frame. So there are several ways of doing this. The one that I think it was the easiest, I'm going to share with you here. I found in Stack Overflow. Basically, we want to get a tuples, sorry, of the series of, let's name this timestamp, then the hour, then the year, and all the information that we already defined. And we want that here and the other thing here in columns, okay? But the way of doing it, let me go here. So expand the data frame. And specify the data in the columns. Now here, as you can see, this is in tuples, but we don't have it in tuples. What we have here is basically a series of, let me actually run it for you, this one, and let me print it so that you can see what do we have, time data. As you can see, it's a series, so it's not a tuple. What we want in reality is a tuple of this row, this value, along with this value. And then from the next series, the next value, okay? But we don't have it that way. So the way to do it that way, I have it in another resource, which is, I think, zip. Yeah, basically here, as you can see, if you zip this, all right, takes the first value of the first list or series and then joins it with the first value of this one, and it makes it a tuple like this. And then for the second value, it takes the second value for the first list, along with the second one, you get this. All right, so we can use this zip function and just zip the data over here. And furthermore, I think you will need to convert it into a list. But that can be done at the end, because here the data frame will accept lists. So here, let's go back to this resource. Hopefully you're not getting lost between the change of resources here. And as you can see, the data frame will take the data now that we have here, and then the columns. So here the data, it will be in the tuples that's specified here in the time data. So let me write that down, time data. Did it have an underscore? Yes, it did. Okay. And then the columns, and the columns equal to, and since we already specified the name of the columns, we'll have it here in column labels. So I'm just going to write column labels. Okay, so this is like the trickiest part of it, but hopefully it's not. Hopefully it's a little bit clear. This is the trickiest part for me. At least for me, it was the trickiest part. But once you read the resources, it will make more sense. Any questions about this part so far? Let me know through the chat. No. Awesome. All right. Now, I think Zoom has a 40 minutes limit, so we might get disconnected, but in case we do, just go to the Slack session channel and I'll post another Zoom link in case we get disconnected. But if it doesn't disconnect us, let's continue. So here you're going to write the implemented timetable insert in the SQL queries. Basically, you'll do the same that you did with the create table, with the inserts, I'm sorry. So you're going to do the inserts, but you're going to do it for the time table. All right. So that's pretty much it. And don't forget your values, and that's it. Okay, now let's move on to the users table. Here is the same that we already did. You're going to select some columns from this data frame. You're going to select specific columns. You can use the dot block for that. And once you have those, you're going to write the insert query in the SQL query. So you will write the insert into for the users. So that's pretty straightforward. And let's move on. Okay, this is the next like tricky part of the project. You're going to implement the songs play table. And now here what it's explaining basically is that we have all the data that we need from the song from this data frame, but there are two specific values that we don't have in this data frame that we would like to have. Okay, and those two are the song ID and the artist ID. If you look here into the data frame, we don't have the song ID and we also don't have the artist ID. We have the song name, but we don't have the song ID, none the artist ID. So what we're going to do, we're going to go through the data frame row by row, and we're going to query a different. We're going to query the table that we already created, which is the songs table, and the artist table, which you have done by now. And you're going to query those. And if you have matching results, you're going to put those results into these two variables. And if you don't, they're going to be none and none. All right. So here it says, implement the song select query in SQL queries to find the song ID and artist ID based on the title, artist name, and duration of song. So if you go here, you have the song select. You're going to create a SQL statement, a SQL query. So you're going to select, and what do we want to select from our songs? From our songs table, we want to select the song ID and artist ID. So song ID and select the artist ID. And we want to do that from songs, but we also want to join, I mean, here this could be selected from artists. We want to join the artist table to get this one on, and then hopefully you know how to do the join, and just look into what these two tables have in common. So of songs, let me do this here, songs join artists A on, and you can just put this like this so that it's prettier. And then let's say for songs, we have artist ID equals a artist ID, and here it is specified that when the title matches what we want and the artist name and the duration, that's the result that we want to get back. All right. So where the title equals, and here you can use this. Okay, why this? Because the title is going to match the title that we're going to fetch from this row, from the first row of our data frame. Okay, so from this row we're going to get a title, which is where is it? Here, song. We get this title, and we're going to provide it here. Okay, and that will, here instead of having this, we'll have this value, which is the name of the song. And if these two are alike, then we're going to fetch that result. Okay, so you're going to do the same for row artist and row length. So where this and this equals, and then you're going to specify the other equality that you want to fulfill, and then you're going to specify the other one. Okay, so that is the SQL part of the project. And then any questions about the SQL statement? Which I already wrote like half of it for you. Awesome. Okay. Now it says select the timestamp, user ID, level, song ID, artist ID, session ID. Okay. So basically, since you're already iterating over the data frame, if you want the timestamp, we already know that it's going to be row.ts because that specific row has a TS column. So we want that result. And we want the user ID, so row, and just make sure to write it the same way that it's found in the data frame. And yes, user ID, it's okay, I misspelled it. So user ID, and you do the same for all the columns names that you want here, that is level, song ID, artist ID, session ID, etc. Okay, then finally says implement the song play table insert query and run the cell below to insert records for the song play actions in this log file into the song plays tables. So here you're going to you're going to write the insert into and then write the values, and don't forget to add the symbols. And basically here you're going to, the values are going to be this that you've specified from iterating from each data frame row. Okay, so this is basically the ETL, and at the end you can run the test Jupyter notebook to see that you have successfully added records into the table. So when you run the test, you won't get this because this is the final product, but you should be able to see at least one result for each table. And this one will be definitely populated like this. And I think the song play as well will have something like this. The rest, like users and songs and artists, will only have one result because that's what we specify in the ETL. So that's how you know that you are on the right direction. Any questions so far? We're almost done with this. Awesome. Okay, and then finally it says use what you've completed in the ETL notebook to complete the ETL file where you process the entire data sets. Remember to run the create tables before running ETL and run test. All right, this is the final part of it. So here you can open the ETL and you can see that it has some parts that are empty. What you're going to do, you're going to, basically you can copy the code that you already wrote and write it into that file. So here, for example, we have the open song file, we added the DF for that, and we already have that code. So you can just copy it and put it here. Then insert song records, song data, and we already have that here. So you can just copy that and put it here. Artist data, what you wrote for the artist data, you can copy it and put it right here. Then the log file, open the log file here. You already wrote some code for that. You copy it and you paste it in the other one. Filter by next song action. We already did that. So you can just right here, copy it and put it here. Convert timestamp column to datetime. You can copy it from here. And then insert time data records. You have these three variables that you already wrote. So you can just, where is it? Oh, it's right here. So time data, column labels, and the time df, you can just put it here. All right. So you just keep going. It's pretty straightforward. If the test Jupyter Notebook ran successfully, you should have no problem just copying the code from this file into this file. Any questions about this part? No? Awesome. And now what you're going to do lastly, you're going to run the Python create tables, okay? And once you run it, now you're going to run the etl.py. So your Python and the etl.py. I won't run it because I will get an error since I didn't copy the code. But you will see that it will process all the files found here in the data folder. You will see it processing all those files. And now if you run the test, now you should be able to see these results. As you can see, my table's already populated, and you should be able to see your tables populated as well. And that's that. When this runs, you have a working project. All right, so be really happy because you came all the way to this part of the project, and you just have one more task to do, which is the README file. And the README file, basically, you're going to do these three things. You're going to discuss the purpose of the database. So why is this database important for Sparkify? And justify your schema, which is this. Why have these 5 tables? And why use a ETL pipeline? And finally, provide example queries and result for sampling analysis. This is optional. And here you have a guide for markdown syntax. So here you're going to open the README, and basically you can use the markdown to write headers, like this is a header. Okay, and just like, just specify the 3 things that they're asking here from you. All right, so why is this database important? Justify the creation of those 5 tables, and you can provide example queries. Once you're done with this, don't forget to save each document, and you can just click where it says submit project, and you have successfully submitted your first project. As easy as that. What can you expect after you submitted your project? A reviewer will review your project. It says in the FAQ Udacity page, it says that it can take up to a week, but in my experience, it usually takes just 24 hours at the most, at least in my experience. So if you submit it today, if you submit it tomorrow, you wait 24 hours and then get a review from your project. The reviewer will take the rubric and will tell you which specifications you did meet and which you didn't. And for the ones that you didn't, the person will tell you why you didn't meet them, and most of the time will provide resources on how to meet them. Okay? It's really important that you understand that the projects are not graded, but you only pass a project until you have met all the specifications, all the requirements. So feel free to submit it as many times. As soon as you have a working project, submit it, and then the reviewer will tell you if you have to work on certain requirements. So I suggest you start working on the project. If you finish it before the deadline, submit it then. So in case you didn't meet any specification, you will have enough time to work on that specification. And that's basically the project walkthrough. Hopefully it wasn't too long or it wasn't hard to follow. But I think it gives you a clear overview of the project from the beginning all the way to the end. So let's open the space for questions. You can use the chat for questions, or you can use, or we can do it through the. You can unmute your microphones. Let me know through the chat if you don't have any question, or if you need to unmute, you can also unmute yourselves. Awesome. All right. So it seems that everything is clear. If you do have questions after this, I mean, I'll post the link for the recording, so you will have this. You can watch this as many times as you need. But if you still have a question, please don't hesitate to ask the question through the Slack channel, and try to do it through the Slack channel and not through a DM, because everyone benefits from your questions and from your answers in the study group channel. And I'll try to get to you I'll try to answer you as soon as possible. And if you still have like further questions, don't hesitate to schedule a one-on-one call meeting. So that will be all from my part. And once again, it was great talking to you guys, and have a great learning week. And I know you'll be successful with your projects. Goodbye.